Okay. Yeah, recording.
Yeah.
Great. Okay, well, thank you guys for joining. I'm going to start with a brief presentation. It is I've aptly titled it a pedagogical pathway to PLCs. I like the just getting the PLCs. Oops, getting the PLCs the P's in there. Okay, so can you guys see this?
Yep.
Okay. Just waiting for my computer to catch up, so bear with me. Okay, so what we're going to talk about today. What's a PLC and why is it important to you and your students? Progression for learning PLCs. The recent blog post that we put out was a 3-step pathway to learning PLCs. So we'll talk a little bit about that. There's some great resources out there. I bet there's a lot of these resources that you guys have in your possession. You may not realize it, what they're for. So let's talk about those. And then we're going to go over what I'm calling the low-cost starter solution for the mech lab, something that's appropriately sized for the mech lab, and I think that most schools can afford. So, first of all, we're going to talk about what is a PLC. So, again, some of the basics. What is a PLC? It's a programmable logic controller. You can call it the brain for industrial automation processes, and everything's kind of plugged into this. Just think of it that way. Your motors, your drives, the control of your valves, they can be networked, but this is what is controlling your process. If you didn't have a PLC, you might look like this cool guy right here, and having these banks of relays that kind of connect like a computer almost, but you can imagine the amount of wiring that goes into something like this. And so what a PLC consists of is, you think of it as like a light switch, just a light switch turning on a light. So you have inputs, the light switches your input, going into the PLC, it processes it, and then you've got an output, which is a light turning on. The difference, again, if you take a light switch and just you turn the light switch on, you get one outcome. You turn the light switch, it goes on. With the PLC, your input, you can have that light switch going into the PLC, but you can then have the process of that PLC giving that light a different output, different states. So you could have the light turn on, stay on for a second, turn off. You have it flashing multiple times, then turn off and stay off. So you can do all kinds of other things, and you won't need to look like this guy right here and do what he did. So with a PLC, you can just simply go to the program and make an adjustment to the program. So the next thing, what has to happen is a programming application is going to be written to define the I/O and what to control for the process. And there are 5 standardized programming languages according to the IEC. If you didn't know that, it's not just about ladder logic diagrams, but they are the most common. You'll hear those. Your function block diagram is another way of programming. They have what they call sequential function chart. It almost looks like a flow chart. You have an instruction list, which is more like, I don't know, might see like Python or G code kind of done this way. And then there's structured text. Again, that's more like Python or something. But those are the 5 main programming languages. And depending on the manufacturers, and if you can see it in the upper left-hand corner of this one right here, so structured text, says RS Logix 5000. RS Logix 5000 is from a small company called Rockwell Automation. And, you think of Rockwell, and I always thought of them, I'd think about ladder logic diagrams. And they obviously are doing more than just that. They have different options And in my research that I've done, they can both be used within the same program. So there's not just there's not just one way to program a PLC. So just like any computer, there's the CPU that makes up, that does the processing power, is going to scan. It's going to read the inputs. It's going to execute a program. It's going to write it to the outputs. And then you've got communications that are all that are within the PLC, or it could be communications externally. It could be like a network, like an Ethernet network that it communicates this to. There's also within the PLC, there's diagnostics, so it might be scanning and looking for any kind of issues. But it's doing this constantly. It's doing this on a microsecond, every couple microseconds, whatever it's scanning. So yeah, and this is really another important thing to keep in mind, is that is how important PLCs are to as a part of what Industry 4.0 applications are. So if we look at this automation pyramid here, communicating, PLCs are kind of found on that second level of this pyramid. And they're communicating down to, I don't know, you'd say the unintelligent components, like a sensor. Doesn't do good by itself, nor does a valve, but it's controlling it down there. There's also networking that goes on within this, up to the higher levels, and then outside, to the Internet of Things. So PLCs just have they play a role in every part of your automation cycle. And so understanding the PLC, the knowledge runs very deep. You have to, go way beyond just programming, and really comes into architecture, the architecture of these components, how they fit within a system. So why are PLCs important now? And I look at this from the student perspective. It's because they're found in so many different fields. Obviously the obvious ones are manufacturing, robotics, automation, renewable energy, wind turbines. There's a PLC, multiple PLCs in those wind turbines. And you think about, so we look at the technologies, and the technologies that are needed to be understood by these students, and then what kind of skills and competencies do they need to develop to understand and really become proficient with working with them. And those are, like, for PLCs, it's developing logic, problem solving, troubleshooting, and designing.
Graph paper. How do you do that? It should be there, but it's not.
Look in the drawer.
So now, for you, how can you make sense of the technology as an instructor and effectively teach your students? So I'm going to pause there for a sec. I'm just going to pop out of my presentation here. Say hi to a couple people here. A couple faces. Hello. Dave Bashon, how are you? So what I want to say to everyone too is that I have, when it comes to PLCs, I wouldn't claim to be an expert. I mean, I've been in the industry for industrial automation, was in it before starting AET. And I've known just enough to get myself into trouble. So I know basics of it. However, what I've also, over the years, being in the educational side, on being an educational consultant, I feel like I've been able to kind of develop this sense of where the schools are having difficulties. And so I wanted to put this presentation together just from my experience and my perspective. I think I'm seeing a perspective that brings in something from the industry, brings a little something from as an educational consultant, and also the challenges that I hear from everyone out there. And after dealing with and working with everyone for skills and the skills mechatronics competition for all these years, I wanted to address these things. And I want everyone to see that this is not a, it shouldn't be considered a black box technology. It's not that difficult. But again, there's a progression to the pathway of learning them. And if you take it in those small steps, I think you'll find it to be a little easier. I did. And so the time, and that's the thing about it too, is I find talking to so many instructors out there, it's the time that it takes for you to put into that to really come out with a good understanding of it. So I'm hoping that once we get finished today, you'll kind of understand from my perspective, hopefully give you more confidence in how to go about working with your students and teaching them this. Okay. So I'm going to go back and continue my presentation here. Nice to see the faces here. Hi, Angela.
Hi, David.
All right. Let me go back to my presentation. First part was just a little bit about what PLCs are, and that's all. Okay. Back to this. Come on, computer, catch up. All I see is a blank screen. I don't know about you guys.
Same. Oh, it's loading now.
Uh-oh.
Oh, no.
Oh, no, I'm seeing unresponsive. Oh, geez. Okay. Let's go back to Teams here. Okay. Technical difficulties. Give me just a moment here, if I can. I'm going to refresh. Well, this is just lovely. My presentation, which I've been working on for days now.
Oh, no. Day in the life of a teacher, David. Day in the life
I
of a
know,
teacher.
I know.
Give it some time, it'll come back up.
It always does, right? Okay, I'm just going to try a couple other things here. That page is unresponsive, so I'm going to just try something else. All right, it's coming back up again. Can you guys see that now?
Mm-hmm. Yep.
Okay, great. Great. Okay, where was I? I was down here someplace. I talked about the different programming languages, how the PLC works, why it's important, and I was last leaving off here. How do you make sense of this whole thing? So, hopefully I'm not. Okay, there we go. So you guys can see that?
Yep.
Yep.
Okay. Okay, so progression for learning PLCs. I look at it this way. This is kind of how I've learned, and I tell this to a lot of different people. First thing is all about, it's my made up words called symbology, but it's learning schematics, the symbols, and using simulation for that. The second thing I think in terms of learning PLCs is our skills building. So it's taking those little steps and applying them. And there are skills along the way with learning PLCs, and the PLC by itself is really, I guess it's really not a lot of fun. So having the skills are, okay, the PLC itself, wiring it, learning how do you wire the PLC itself, looking at the I/O, not just taking a training system, but starting from scratch. Third thing is, again, there are 3 steps to this: developing the PLC programming competencies, and so we'll talk in more detail about each of these. There is a 4th step though, and that what I say is apply PLCs to do cool, motivating applications. So that's not part of the 3 steps. That's actually 4 steps, but you know, that's where the fun motivation, I think, for the students is to see the end result and see what they can do, think out of the box. So, okay, symbology, schematics, and simulation. Fluid Sim, if I think most people on here right now know what that is, but it's a simulation software. Comes free with your mech lab when you buy it. You know, this is where it all starts. And I'll say even within Fluid Sim, there is a PLC emulator in there, which uses kind of sequential function chart programming, more with Boolean logic. So you can get a lot within that Fluid Sim package. Additional skills building is with the mech labs and with this other training system here called the LC21. These are, you know, in the big scheme of things, for an expensive field to be working with and be teaching students in, because the equipment can get very expensive, these are low cost systems, again, relative. But this is where, you know, the system on the left, your mech lab system, is a pre-built system. You know, the system on the right is something that the students would actually build up. It's something you'd find within a control cabinet. Essential skills. Okay, additional skill building is with the microcontrollers. So, you know, these aren't training systems. These are just purchased off the shelf PLCs. They're cheap. Again, some of them more expensive than others for sure. But there's more than just these ones. These are the most common ones. The Micro series by Alan Bradley, Siemens logo, the Eaton. And then the click is just down and dirty, and which is what I selected for this project. But I could have done this with any of these, but I chose the click because of it being cheap. This is my project right there. So I'm taking that conveyor system and applying this PLC to it. So we're going to come back to this in a moment. For those of you out there that have PLC training systems, and if you've become proficient in them already, that's great. You can certainly apply these to the mech lab system, and you can apply them to the little LC201 that I showed you, or any other system. You just have to have the right understanding of how to connect to the outside world. Okay, but these are, you know, PLC training systems, so they're different, of course, than the little microcontrollers that I showed you. How are they different? Well, they're still PLCs. These are PLCs that are pre-engineered, though. They're pre-engineered systems. They're trainers, and that's the main point I want to make here too. You buy a PLC, like a Click PLC, you got to do everything. You got to wire it up and everything. And look, these little PLCs are limited. So the training systems are generally going to come with a more robust PLC, greater capability. This advanced PLC trainer has got an HMI built into it. It's got a compact Logix PLC. This Edge trainer's got a lot going on with it, as well as this other one right here. So what is the difference between buying that little PLC and buying one of the training systems, and how are you using it in the progression to learning PLCs? Going back to the little microcontroller, you're gonna, you know, there's so much information online for putting together, for learning the PLC itself. I taught myself using that, along with some of the Festo LX training programs, but it really is, there's just so much content on there for those little micro PLCs. Students should be used for students to kind of get them hooked. This is where you're going to be kind of building your skills, the essential programming concepts. These systems come with structured multi-level curriculum. It shows they're of course self-contained, and they work with other systems. As I mentioned, you just have to have the right wiring, the breakout boards, and everything. Ultimately, what I talk to people about, why buy a training system, it's about time, task completion. So completing a task within a certain amount of time. So you only have so much time with your students in the classroom. So this is where you need to kind of push through all this information, how to create a memory function, how to do a timer, a counter, a latching program. This is what is going to have those essential, this is where they're going to build those essential skills. These pre-engineered, pre-designed systems then can plug right into other systems. So that if you purchase like a Festo pneumatics training system and just have it for doing electropneumatics, this system can reside right onto the headboard of that training system, like it's being shown here. So time, task completion, people saying, oh yeah, I want real world stuff. I don't want kids to be plugging in banana connectors, this and that. And I agree with you. And that's what those skills building packages are for. This is about completing tasks quickly, efficiently, learning a lot of content. You don't want to have them bogged down in screwing in wires and terminating things. That's not what this is about. And this is the concept for it. Applications. So now let's look at some more motivating applications. This is a whole set. Some of you may have seen this. I know a number of schools have these. The classic traffic light, a little process control operation. Then there's some other really cool things where you don't even need hardware, outside hardware. You can have a PLC right here. You've got this device that's called an Easy Port, which is similar to, this is kind of like a combination of Easy Port, which works on the Mech Lab, but also plugs into your computer and also works with other pieces of real hardware. But in this case, they're just demonstrating software. So you can actually control, through your PLC, control the system on your screen. So I know there are many schools that are part of this Industry 4.0 program that have purchased like robotics and automation software. And this software right here can be controlled by your PLCs. Here's another one that is controlling, it's called Easy Veep. It's controlling just little automation processes, an elevator, a garage door opening. And so it gives the opportunity to again, apply the knowledge. Of course, you can take it to the next level, which is, systems like the modular production system by Festo. This gets into more Industry 4.0 concepts, but the high level progression of where you are going, and then to eventually get into doing things with cyber physical factories. Okay, so everything we talked about, there are resources available. The micro PLCs, yes, there's a whole curriculum that Festo has for those. Not for Click, it's got to be based around the training systems. But again, if we're talking right now about the standard equipment that Festo offers, Festo provides instructor guides, student manuals, provides hard copies. There's also site licenses. There's a Festo LX learning experience. And then there is Train the Trainer, the NC3 Train the Trainer program. So there is going on right now a PLC. I think it's probably starting this afternoon at 3 o'clock, or it already started, a Train the Trainer for PLCs. So, and then of course there's AET Labs. So if you have questions about this stuff, you want to talk more detail, please reach out to us. This all kind of funnels into this Industry 4.0 program. And so it's a progression. You'll see in here, PLC fundamentals is the first level. There's a PLC or applied PLC in the second level, and then there's an advanced PLC in the third level here. So there's a long ways to go, and there's a lot of equipment to be able to control with your PLC. So So talking about the resources again a little bit more, because I think a lot of people that will be tuning into this, whether now they're here now or the recording, they have mech labs. If you have a mech lab system, you'll notice that you've got, right where the easy port plugs in, you've got this 15-pin D sub connector male. Some of you may have received these connectors right here. These are little breakout boards. I included some of those, or we've included some of those when we sold these. And the idea was this is meant to connect to a PLC. So you may be wondering what those are. So you have those. Now, if you also have, again, if you have a PLC training system that looks something similar to this, you need to connect to the real world or connect to a device. And that's where you might have had this syslink cable. I've included some of those with the EduTrainers. And this would plug in right into the ports here. And these flying leads would then connect to that little D sub connector that we talked about right there, little terminal block connector, which would then go into the port of the mech lab. Also, if you don't have, take this out of the picture right here, but this guy right here can also terminate with your smaller LC201s, and again using relay logic in some cases, but there's a power supply that comes with this as well. So there's a number of resources out there. You have them, but now I want to talk about this low-cost starter solution. Before I get there, though, does anyone have any questions? Okay.
Will you share this slideshow with us, David?
Of course.
Thank you, sir.
Yeah, of course. Okay. Okay. So I don't know if anyone has or has not seen one of our blog posts that we put out, I think, a couple weeks ago. And really, I think where I'm at with this and where I want to, engage with you guys on is questions on this, and because I've the point of my blog post, which I'm going to just go back to really quick here. All the information's right here. Okay, so if anyone is wondering about this, where did this come from? What are we talking about? This is on our home. If you go to our home page, and to the bottom of our home page, you'll see all of our blogs, what's new, and this is called the PLC Starter Solution for Mech Lab Classroom Project. So essentially, this is what we've got here, and this what I'm providing, here is a list of components. A list of components that you guys can order and have, it's all, all the work has been done. You guys don't have to think about this. And I can't take full credit for this. I've got to give a shout out to my friend Dean over at Monty Tech, who kind of helped me get started with this. And I've just taken it and added more details and put it into this post. So and I ran through it myself too. So I know what I was up against, and it didn't go smooth at all. So and so that's what I kind of want to do, is I want to share my experience that I had with this. And so again, you can refer back to this at any point. I'm not here to go through that. You can take a look at that. I'm here live instead to share my experience and talk about it. Yeah, so anyways, we'll talk about some highlights here. The PLC. This is a Click PLC right here you're seeing. This PLC itself cost $190. Okay, it's cheap. I actually went on again because I wanted to find something even cheaper, and they have a whole bunch on there. I got this is for $110 for this guy. So $110 for the PLCs, as cheap as $110. But this is the one that was recommended to me by Dean from Monty Tech, because it's what he's used on his. So I went with that, but I think I haven't got to using this one yet, but 110 bucks. So the software is free. So the software is free. It's purchased through the company Automation Direct. You may have heard them. They've been around for years, and they're all about cheap automation solutions. Now, I don't know if I'd want to trust running my factory with all their components, but I think there's definitely some value in what they have to offer. So start with a PLC. Again, everything on that's on the blog is laid out, talked about. You need a DIN rail. It's good to have a DIN rail to mount the PLC to. You can cut that to size. I've got on there these terminal block connectors, and these are just, I mean, hell, you could just do it with wire. You could connect everything with wire nuts if you wanted to, and do things up that way. But this is a much cleaner way of doing it. These just kind of plug in here like this, and just snap on. You get different colors. I got some different colors to show the difference between maybe my power, my power down here, my inputs, and then my outputs. I didn't have the chance of doing this one over here, but okay. Let's see. Beauty of these PLCs. Again, what I think this is such a well sized and appropriate system, or appropriate PLC for this system right here, is it operates on 24 volts. So, and that's what I think everyone really likes is, they know the kids aren't going to really hurt themselves too much with 24 volts. They can, I'm sure they could find ways of doing things, but 24 volts. I took you know what I've got, what I'm using for the power supply? I'm using the power supply from the MechLab system. So the power supply from your MechLab system is powering this thing up here. So I'll try to hold this up a little closer so you can see all that's made up. So there's your power supply right here. Goes in here, and then what I'm doing is I'm tapping off that power supply, so powers up the PLC, but also enough to power your I/O. Okay. So now, if you start to get into components on here that draw too much power, too much amperage, then all bets are off. There are external power supplies you can get, but again, we're keeping this in the context of using a MechLab system. So I kept my wires different colors just to make sure, just for my own sanity, but which is good practice. But so you can kind of see those here. Inputs I got going black, and my outputs are my red, or yeah. And on the other side over here, this is my breakout. Now let's say this is my cable with flying leads, and so this cable comes like this. I ordered this one off of Amazon, so I think it was like 15 bucks. So what's nice about that, and it's a very important consideration, is, well, the fact that they gave me, if you can see that right there, that's my pin numbers, my pinouts, more commonly referred to. And so you'll now know, and these are some of the things that I learned going through this. Number one, I mean, I got hung up on the wiring because I know enough, just enough about electrical wiring to get myself into trouble again. But I think I made it pretty clear on the blog post about how to wire that up, what some of the considerations, just so you didn't get bogged down like the way I did. But the pinouts are really important, and so knowing where these ones go. So you then take this wire right here is going to the MechLab here, plug it into that D sub connector, and it's powering up just the way it is right now. It's powering up the inputs. So I got my LEDs on. Then the other important thing you need to know, so the other side of this D sub connector, you got pinouts there. So the pinouts that are shown on this right here So you'll know, oh, okay, so I got for my Y1 output, I know that you really should go backwards. So looking at your multi-pin contactors here, what are those connected to? Well, let me put that back down there. This is something else I posted on there too. So this is the multi-pin connector, they call it, that's on the Mech Lab. And you'll look down the bottom here, you can see that. You can see the pinouts right here. So for every, multi-pin connector, there is a specific, every socket, there is a specific pin on your D sub connector here that it's associated with. So you associate multi-pin socket number 1 with pinout number 0. And then you say 0, I'm sorry, plug socket number goes to pinout number 1. Pinout number 1 goes to black. Pinout number 1 is black on here, which then goes to here and connects down to here. So that is, I will say that is crucial. And again, it's spelled out in the blog post. I spend a lot of time just figuring that out. Of course, plug it in here.
But we need to get that cord from you because we can't just get another cord because they may not match with those particular colors, correct?
Yes. Yeah, well, again, if you had a cable like this and it wasn't the same brand, as long as they provide you the pinouts, most of them should, they provide you the pinouts on it, and then you just match it up. You match it up.
When we buy
to
cables,
this.
it just comes out a cable, it's got the ends on it, you have to cut it off, and then you'd either have to ohm it out to make sure you have continuity through each lead.
Yeah.
It's pretty time consuming.
Well, that's why you get the one that is providing you the pinouts on it, like this one. This is right on Amazon. So there's that, and of course the Mech Labs too. If you look in your documentation for your Mech Labs, you're going to see this same document here.
Yeah, we got those
so,
trainers like during COVID, and we really didn't get training on them. And I had a flash drive or something with information everywhere. You don't even know where to look to find it because it was like a zip file folder, like a Google Dropbox or something. And I opened that thing up and I'm like, you don't even know where to begin. You know?
Well, Dave, you're in luck today because you got me here. I'm going to tell you where to find all that stuff. You can get all that stuff right online. Yeah, well, we can talk offline, but the Festo info portal, if you Googled Festo info portal, I don't know if one of our AET people that are on here right now could maybe share that link in the chat. That's huge. Whenever we talk to people, first things go there because you get updates on the software and get updates on you get all the curriculum and data sheets and everything that you're talking about, Dave. So yeah, for sure. So, okay. So once you've got that figured out here, then it's just a matter of programming this thing. That's another entire set of skills that needs to be developed. And I use that loosely because it's you can get immediate outcomes from programming this. It really is not that difficult. In fact, I call this out in my in this blog about let me see if I can find it. I want to share this. I'm not going to share that because that won't go, but I'm just going to go into the Click PLC software. This is the Click PLC software. It's called Click Programming Software. And everything that I've developed here for this, for the program that I have in here right now, was taught in the lessons that they have online that are probably 12 plus years old by a couple of guys. And I think I gave the link on the blog as well. It's really, these are just simple timer on, timer off circuits done with, there's a instruction list on the side here. And this is kind of like a ladder diagram. These are your rungs. But I'm not here to kind of get into the details of it. In fact, I kept on experimenting because I didn't quite get this to do what I wanted it to do. So when I had time, I kind of jumped in here. I'm like, okay, let's see if I can take this one step further. Way I have this thing programmed, again, this is a real quick reward for students. Again, if you follow the programming that again literally takes 30 minutes, there's like 30 minutes total of like 10 different videos that range to average around 3 minutes each. You'll be able to just, if they follow the programming instructions on it, they'll be able to do this real basic circuit or program that'll control this. You put it on here and it just turns it on. Actually turns it on and then turns it off real quick. But like I said, this is where it becomes real fun. You know, you take this and like, okay, let's get it. So when this sensor right here does sense this object, it keeps it on for 5 seconds, which is what I did. So it turns it on and keeps the conveyor on for 5 seconds. So what else can you do with it? And I really do think that's where the students are going to say, wait a minute, yeah, what else can this thing do? That's really cool. Okay, well, there's another sensor on here. There's an inductive sensor. And so the inductive sensor is used to detect the difference between like a metallic shiny object and a dark object. So put that on there and it's supposed to separate it out. I'm trying to figure this one out. I haven't got it yet. But what I did figure out, which was really neat, is I said, you know what, you know, in some automation processes, you'd have things where as things start to stack up, they want to have a light that goes off. If you got a MechLab system with an expansion kit, you got additional actuators in there, valves, and sensors. This is a sensor that came in our kit. I'm like, oh, put that on here. How fun is that? So what happens is, as this thing sorts these metallic objects, and as they go down into the chute there, they're stacking up. And as they stack up, they're going to get to a point where it needs the process needs to stop. So somebody can come over and there it goes, and the light turns on. So there's a sensor right here. As these things start to stack up, the light, this little sensor senses. There's a timer in that program, counts 5 seconds, and then the light turns on. Well, there's also a way you can make this thing flash every half a second. I was trying to figure that out too. I couldn't do it in time for this, but it's little wins like that along the way, I think, that can get the students, keep them motivated, doing things, you know, doing something different. And this is all out of the box stuff from what the standard MechLab offers. And you can do so much more beyond this. And for anyone that is going to be at the Skills Mechatronics competition, I'm hoping to really show you some impressive modifications to our entire system. So, does anyone have questions?
Yeah, I have a question. So instead of using FluidSim to control the MechLabs, you're using the PLC. So it's an either or, right?
Yes. Yeah. I in my presentation, I was talking about how FluidSim is, you know, understanding symbology, schematics is super important. And that's where FluidSim works phenomenal. And that would be through your
Well,
easy
I love
port.
FluidSim. You don't have to sell me on that. I love it. My
Yeah.
students love it. It's a great. I think it's an excellent tool. And I think my disconnect was that it's either or. For some reason, I was thinking I couldn't see how the two of those were interacting, but they're not. You're using either the PLC or FluidSim. So now I'm crystal clear. Cool.
Exactly.
you.
It's like the next step, Tina, is what it is. That's where I think where this comes in play.
Yeah, so I have my kids doing the mech labs and I have my kids doing the PLCs. And so what I wasn't sure was that whole interface because I'd never seen it working. So now with this demo, it's much clearer to me. So thank you.
Good, good. You're welcome. Dave, if if you guys are just still coming up to speed with the mech lab, we can absolutely have another conversation and I hop on a Teams call and we could go through what you have there and talk about some of the resources.
Excellent. I love that. I tried getting some of the kids to use it. I mean, I'm versed in some PLCs, being out in the field. But I wasn't familiar with the Siemens model that you guys had. So it took me some time to try to figure it out. I figured it out. I realized in our mechatronics lab, I didn't want to corrupt that program, but it wouldn't allow me to create a new program to kind of like make the PLC trainer in that system to make something else, put a new program on it. It almost seemed like it was locked out. You know anything about that?
Yeah, you probably need, first of all, you probably need the programming cable. There's a specific programming cable, and you also need the software, the Siemens software. I forget exactly what they call the Siemens version. Alan Bradley's got Studio Ars Logic's 500 and Studio 5000. That's for Alan Bradley. Siemens uses for some reason I can't remember the name of it, but they have their own version of that.
Systematic, or was something like that maybe? Or I thought we had it, and it just would not allow us to communicate. It did seem like we had the cable, seemed like we had everything that we needed, but for some reason, it's like we didn't. You almost needed like an administrator code or something to put in that. I'm like, I just want to make this into a PLC. Just dump a new program into it. We didn't have like with the Fluid Sim software. We had some of those. I'm not familiar with that, and when I was trying to find the information, I was just struggling. So I kind of gave up on those. I felt like I was running for my life with this stuff, to be honest.
Yeah.
But as long as I can get some helps in some certain situations, I'm sure I'll be able to figure it out. But
yeah, Justin will get in touch with you. We'll set up a time. I've been really trying to help people out with this, and don't want anyone to be frustrated over it because it shouldn't it's not that difficult. I will tell you though, communication between the PLC and your computer, and this is a lot of the frustration that people deal with. Not only that, but loading the software on the computers, the licensing and everything like that. That in itself is there. I will tell you that you get into the Festo curriculum, it covers a lot of that when you get into their training systems. It'll talk about licensing, licensing and how to get it to communicate using the Ethernet. I want to be able to communicate with the PLC. So that's stuff that you can't overlook. So. The other thing I'll say is in this type of setup right here, between Fluid Sim and the components that are in here, and even this PLC, I don't think I've talked to some instructors and they feel that before they give to the students, they want to make sure they know all there is to know about these things, and I'm just like, well, you're going to have to spend a lot of time to really, get into that and to know that. And I don't, in my opinion, I don't feel like that's necessary to have to implement this program. It's not necessary. There are so many resources that Festo offers when it comes to the mech lab systems, the curriculum, the instructor guide, the student manuals. It's there. I think be honest with your students. If you're not comfortable with it, let them know that, hey, look, we'll learn this together. You can make mistakes with this. No one's going to get hurt with this. You're not going to, this is an industrial little system. These are industrial components, just scaled down. No one's going to get hurt. So let them experiment with it. And Fluid Sim's a great place for that, for sure. No doubt about it. But it's when, with the PLC, you can do so much more when you have the PLC. And that's what opens up the possibility, I think, and what's going to get people to really, get the students to really get hooked. All right. Hey, if anyone else, you guys know where to find me. Feel free to reach out to one of our consultants that you may be working with, or respond direct to any of our communications. We'll help you out, make sure that you know what's going on with this. We don't want to see anyone frustrated. We want to see everyone succeed. Thanks. Everyone
Thanks.
Everyone have a great day. Good luck with everything.
Bye.
Thank you,
Bye.
Dave. So how do